Hi, this is Anmula Shruti with my partner Vempati Nagabharani are presenting our final project. We chose the topic Sentiment Analysis using Apache Spark. Let me give you the project overview. We built a model that could do sentiment analysis on any product. We have used social media Twitter to gather the tweets and then we predicted the sentiment of each tweet. Sentiment could be either positive or negative. We then aggregated to give the popular sentiment for that product or topic. In order to achieve this, we have used Spark machine learning library to create the model and we have used naive Bayes classification algorithm which is built upon Bayes theorem. We trained the model on AWS EMR instance as we trained on big data. Then we imported the model onto the local system where the application resides. The web application was built on Flask, which takes the user input as the search topic and it calls the REST service, which gathers the tweets for that topic and analyzes the sentiment using that model. The main goal of the project was to create a sentiment model that is available for users, which is in a user friendly fashion. Now, what is sentiment? Sentiment is nothing but a feeling or emotion. In other words, it is called attitude, opinion. In the current generation, every company is interested in finding out opinions of users for their products. This is called opinion mining, and it is mainly useful to determine the attitude of users or public towards a topic. And sentiment analysis is especially useful in social media monitoring.
Spark. Spark is a powerful open source processing engine which is built for lightning fast computations. The diagram you see is the ecosystem of Spark showing different modules available in Spark. Spark machine learning library module, which we have used for a project, provides various APIs and algorithms to perform supervised learning and create machine learning models. We have used Spark's implementation of naive Bayes classification model. Spark supports different languages like Python, Java, Scala, SQL, and R. We have programmed our model in Python. Naive Bayes classifier. Naive Bayes classifier is a supervised learning classification model which has its roots from Bayes' theorem. It is a probabilistic classifier. Let us understand using an example. Let's say there are two classes, green and red. And now we want to classify a new object into one of these classes. The model first computes the probability of any object to be in either of the two classes. Then, based on the features, it calculates the likelihood of the object belonging to either of the classes. The product of these two measures gives us the probability of an object belonging to each class. Depending on the results, the classifier outputs the class the object belongs to. We have to provide model with features while training and predicting. Features extraction is an important step while creating a model. We have used term frequency and inverse document frequency method to extract feature vectors. It gives the importance of a term in the document in a corpus. It first calculates the frequency of a term in the document, let's say it is denoted by TF. It then computes the frequency of the term in the whole corpus, known as document frequency, let's say it is denoted by DF. And is a term that is used in a document very frequently. It's a common term. So the document frequency would also be very high, but it really doesn't attach any information to it. To avoid this, we compute inverse document frequency, which reflects the measure of how much information a term provides. So a word like an provides very less information. So the IDF value of it would be really, really low. This avoids attaching importance to irrelevant features. We then lastly compute TF-IDF measure, which is the product of term frequency and inverse document frequency. The advantages of using naive Bayes classifier are It's fast and efficient. It is used in multi-class classifications. It is widely used in sentiment analysis models. It is not sensitive to irrelevant features, and it can handle real data. The main disadvantage of this model is that it assumes independence of features, which might not be the case in some scenarios. Architecture. Our system architecture consists of two parts. One is for training, the other one is the application. For training, we have used AWS EMR cluster. Our training data is a publicly available Twitter dataset with more than 1 million records. Since it's a big data, we needed higher computation power. So it was economic for us to instantiate a AWS EMR cluster, train the model using the data, save the model, and retire it. We then developed a web application that uses this model to predict the sentiment of tweets about any topic. We've exposed our model as a web service using Flask Python web framework. This allows a user to input any topic and get the sentiment for that topic using our model. To understand the basic workflow of the application, it starts from when the user inputs the product or brand name for which he or she wants to find out the sentiment for. This goes as a GET service call to the Flask controller. The Flask controller then forwards this request to the sentiment analysis module. This module then asks the Twitter data module to retrieve all the tweets generated for that particular product or brand. The Twitter data module uses 3B to get the tweets real-time and stores these tweets in the file system. Once the data is available in the file system, the sentiment analysis module reads these tweets, predicts the sentiment, and outputs it to the controller as a JSON file. The controller then outputs the same to the client, which renders it to the user. Technology stack. We have used HTML5, CSS, jQuery for producing views, Google Chat for producing visualizations in the user interface, Flask to deploy REST service, Tweepy to get Twitter data. Our sentiment analysis model is on Spark. So to install PySpark on Mac, we have used brew script. You can get the script from Git repository as shown and use it to install Apache Spark. It manages the installation for us. We have also instantiated AWS EMR cluster from AWS console. Feature extraction. As mentioned in the previous slide, we use TF-IDF method to extract features from tweets. The getFeatures function takes tweets as input and outputs their feature vectors. Hashing TF is a class provided by PySpark to calculate frequencies of the word in every document. So we instantiate this as a first step and use this object to compute the frequencies. After that, we compute IDF measure. As last step, we compute TF IDF measure, which we return as feature vectors. The create label data here essentially joins this feature vector to the trained data RDD so that the features are mapped to their corresponding labels so that it could be used in training the model. We have seen how to pre-process the data and how to extract features from it. So we are now ready to train our model. We load our training data into Spark context and then transform this data so that we have labels and tweets. We pre-process these tweets as we've seen before. These labels, they have two polarities, 0 for negative, 4 for positive. So now we map these polarities to two different levels, 0 with 0, 4 with 1. And then we create label point objects for every feature and label. We feed this data into Naive-Bayes model so that it could train and we have a model. After training, we save this model in HDFS. We have created a model, so let's see how well we did with the model. We load the model and test data into Spark context. We then perform all the computations on the test data, like transforming the data, pre-processing the tweets, extracting feature vectors, mapping the polarities and creating label point objects. Now we use this label point object to predict the labels using features. After that, we compare each label to the actual label and count the number of correct predictions we made. This will give us our accuracy. Create Twitter PY. This is the module we use to connect to Twitter and get tweets. We have used Tweepy, a Python API, to do this. As a prerequisite, we would need consumer key, consumer secret key, access token, and secret access token to connect to Twitter. Twitter uses these credentials to authenticate user requests. Along with credentials, we send query parameter. It is the hashtag for which we collect the Twitter data that was created for past 1 hour. We also pass a language parameter as EN, which means the tweets we retrieve are in English. Once we have the tweets, we write them into file system as tweets.csv. Sentimentanalysis.py. This is the module where we perform our sentiment analysis. We read the tweets.csv file as input into the Spark context. We then load our naive-based model into the context. We then perform all the pre-processing steps on the input file to get feature vectors of the tweets. We input these vectors into the model to get polarities. We then join the polarities with the input file so that we map the polarity with their tweets. We loop into this RDD to count the number of positive tweets and the number of negative tweets and write them into output JSON along with the tweets. We also find the most frequently used words as word map and write to output JSON. We return this output JSON to the client. Let's see the demo in part 2 of the video.